start with some audience participation. Has anyone here heard of the CAP Award? Oh, very good. Anyone got the CAP Award? Yes, I'm winning. Okay, so CAP is the Certified Analytics Professional Award, developed and run by Informs, who, if you don't know, are the US equivalent of the OR Society. We are pleased to say, speaking on behalf of the Society, that this will now be offered as part of the OR Society's offerings, and I'm reliably informed there are leaflets on the desk. Yes? Okay? Okay. Okay, they are there, so yeah, if you are... Ah! So in the spirit of full props, then... There we go. This one here. So Exhibit A, the leaflet that is in your bags that tells you about the Certified Analytics Professional Award. I was asked to give a quick talk about this because I actually passed the exam in July 2015. I had to check my emails to be sure that was the date. As part of really our due diligence of taking the exam on. So I was asked to come here and talk for an hour about this. I then thought I haven't really got an hour's worth of things to say about it. So I'm also going to tap in a bit of my PhD research, which fortunately is in the same area. So we were looking at basically the current provisions of university education, specifically around analytics and in response to analytics and big data. So I'm going to reflect some of that in here and really talk a bit about the competition, if you like, what else is out there on the market. So I'll touch on the degrees that are being offered, but also I'll talk briefly about some of the online courses that are also available, and at the same time, obviously, give you my take on CAP. So this is very much my personal opinion of it. I'm not speaking on behalf of the OR Society in terms of my feedback, but I'll try to give you an honest reflection of where I see it sitting, to help you decide if it's the right thing for you. So why get certified? I mean, this is quite a sort of tired cliche almost, that this is a very big jobs market now. The bit on this infographic I thought was most relevant. It's a Glassdoor, if you've heard of them. They're an online jobs board, particularly in America. They have data scientist as the hottest job of the year last year, and data engineer third, and analytics manager fifth. So there is this hype train that goes back to the McKinsey report in 2010, but it seems to not be abating in terms of the opportunities there. Now, at the same time, though, I think part of my PhD research, I spoke to over 50 employers, potential employers of analytics graduates, and quite a few flagged this sort of issue that it's quite difficult to know, to separate the wheat from the chaff, as it were. It's essentially, a lot of these things are not widely known by the business community, and a lot of the degrees with analytics are all relatively new. A lot of the certification is not really verified in this way. So a lot of employers are facing this problem of not really knowing who they should hire and who they shouldn't, and getting that message through. Okay, so I will start. This is my overall structure. I'll talk to you a bit about CAP, the award itself, and some of the marketing bump that Informs puts out. I'll then give you a more general view of the marketplace, so what's going on in terms of degrees, and also some of my reflections and views on the other online offerings available, and then a few reflections on taking the exam itself. Okay, so this is literally copied and pasted from their website and is in full advertising mode, but they talk about the showcasing of credibility. That is an independent validation that shows to the entire potential community your superior knowledge of the entire process. Okay, and apparently if you put CAP on your CV, you will open the doors to new opportunities and professional growth. Okay, so you're all sold, I take it at this point. Take your leaflet and go and sign up. Okay. Now, being a semi-academic organisation, it's actually quite interesting the way they developed the award, and they've written about this online and in papers, and they did follow quite a good process involving trying to map out what actually it is to be an analytics professional, what you spend your time doing, what are the sort of things you should know. So they have these 7 stages, from problem framing to what they call analytics problem framing, which I think more is about formulating the model and understanding the available data. They then have a chunk on data management, choosing the right algorithm, building the model, deploying, and then finally life cycle management, maintaining models in organisations. I broadly agree with their split there, and they've given this various weights to each of these parts, and apparently the randomised questions reflect this weighting. So 15.5% of the questions you get will be about business problem framing. So the actual award is based on 2 criteria. First of all, you need to pass the exam, which is an online computer exam, which you would do in a test centre. I think I did mine in the West End of London. But the other key part of it is prior experience and education. So they have these 2 criteria. If you are a bachelor's degree, then you need to have at least 5 years of analytics experience. If it's a master's degree, you only have to have 3, or 7 years experience if it's unrelated to analytics. And you also need to have this verification of soft skills. What that basically means is you have to put forward a client or a former boss of yours, and they send them a letter and they have to fill in and check these boxes to say you can actually talk to people. Okay? And that is a part of the exam, essentially. So if you don't have those bits, you have to wait until you've got those bits before you can apply. And as with most of these things these days, retaining the title, retaining the certification, you need to show every 3 years evidence of your continued development, or evidence of training that you've done, employment in analytics roles, and sharing analytics experience and knowledge. So you guys have seen this. I've done this today, right? Okay. And surprisingly, this may surprise you, the OR Society will offer such courses, presumably with a fee. Okay, everyone wins. Okay. One key point is that it is not a course. There is very little material they give you in terms of passing this. There's no lectures, there's no lessons. You do get a handbook. The handbook is a good guide to the topics that will be covered, and it does give some information. I can't see how you would pass the exam on the handbook alone. It is basically designed to test that you are walking the walk, essentially, in terms of an analytics role. I don't think there's any prepping that they're offering you that will get you through that. I think we have talked about potentially offering a course on preparing, but certainly you're not going to get that from the online materials they give you. Okay? It is designed for people who have that work experience already, and the question set certainly reflects that. Okay, so that was my first bit. I will go through a bit around analytics education and analytics qualifications in general. So this is part of the PhD work we did. We tried to map out what disciplines really lead into analytics. And you may have seen this in some of Stuart Robinson's presentations. He shamelessly stole it from me and showed it to everyone and became known as his diagram. So I can say bad things because he's in another room talking elsewhere and can't hear me. Okay. We conceptualized it as being really across these 3 things. The technology side of it, the computer systems, the databases, the equipment that is collecting, storing and extracting this data, the quantitative side of it, and then finally the decision-making side of it, the influencing part of it, the more psychological and behavioural aspects of that. And we posit operational research as being somewhere between these 2 things. Obviously, some people are more at the quantitative end of it. Some people will be more at the PSM side of it. But we think it really sits on both of those parts. Everyone's really doing OR in some way to help influence decisions, whether they're being made by human or machine. However, there's various other parts here. So we see information systems as being the combination of the technology and decision-making. And an important part, I think, increasingly in recent years is the growth of machine learning, which we see more as being a combination of the technologies of high-performance computing and the quantitative methods. I've basically said that already. Okay. Then we get to the interesting world of data science and what is said about the skills involved in that. So this was a chap called Chandrasekaran. He listed all of these multitude of skills that one would need to have to be a data scientist. I shouldn't imagine anyone has all of that long list of things, but there you go. I think these are perhaps more useful definitions of data scientists. A data scientist is an analyst who lives in California, and data science is statistics on a Mac. So anyway, a weird and wonderful world of requirements we see in the literature there. And what we wanted to do was have a look at actually what's being offered at universities. Are they reflecting this collage of all of these different skills, or are they more doing as they have for many years previously? So the concept is it some brand new thing where we're getting brand new analytics curricula that's not been offered ever before, or is it in fact an emperor's new clothes? These are courses that have run basically the same and now have a new analytics name. So with that latter idea in mind, we did experiments using classification algorithms. So we extracted a variety of text material relating to the courses themselves. So basically we went to the web pages, scraped the web pages of all their text data, and then we tried to classify them to an existing discipline. We took examples of a variety of disciplines, the same ones that are on that Venn diagram. So we took OR course materials, we took computer science course materials, statistics course materials, and so on. And then we went out and also collected analytics course materials. However, that didn't give me a huge data set. To supplement that, I went onto LinkedIn and took out some job adverts related to these same titles. And the goal of what we were trying to do was predict which discipline an analytics or data science course actually is closest to. So we go and find if the analytics course offered here at Loughborough, is it closest to OR, is it closest to computer science, and so on. And we ran this across the whole scope of UK offerings. Okay? So we had effectively a training set, and for the training set, I actually used the job adverts because there was a greater volume of them. So we first of all built a model based on that, and then we tried to predict other job adverts as to what discipline they should be. At that point, we then introduced the course materials and tried to predict those. Now, interestingly, my algorithm was better at predicting which course was related to a discipline than it was for job adverts. So I think it got the essence of what that discipline was about, but job adverts were a bit more varied. And then the final step was to introduce the analytics materials and see which degree they were closest to. So again, a bit of bit of maths first. So we used a support vector machine, indicated here. So it tries to find the separating hyperplane between the two classes. So when it sees a degree material, it can say, is it this side of the line in computer science? Is it this side of the line in classes information systems? Okay? And we added to that by using a bagging algorithm. So anyone, I don't know if you're familiar with bagging. It's a bootstrap aggregation. So what we do is rather than just having one classifier working, we create random samples from our data and build hundreds of other classifiers. We then take a vote across all of them. So we had 100 classifiers in the end. What degree do they vote in each case? And the average, the highest quantity of votes, gets the winning vote. So my audience participation piece, which of these disciplines do you think had the most degree courses assigned to it? We've got computer science, IS, psychology, OR, statistics, machine learning. Who do we think won? OR. Very good. We did win. Okay. This is, I obviously haven't linked the data properly. But OR was the most common. I think that's at 20. And then we had 17 classes machine learning, only 4 for psychology, 2 for statistics, and comp sci and information systems got 0. Okay? So we found most of the analytics degrees that are being offered in the UK are fairly closely resembled to either OR degrees or machine learning degrees, something that was backed up in other data we looked at. And if we look at the degree titles, the ones that are assigned to statistics were all called marketing analytics in some way. The ones assigned to psychology had this management aspect. Machine learning invariably was called data science, big data analytics, and similar titles. And the term business analytics was very common amongst all the ones assigned to be OR. The TLDR, the long story short, is we basically hypothesised that there's this two-tier system of analytics degrees. We've got data science type degrees being offered typically at computer science schools. They have titles such as data science, web science, HPC. And then we have the business school variant, which are related to operational research, typically called business analytics, or analytics and risk management was common as well. Adding to this, we also looked at some employer perspectives, and I did interviews with about 50 potential recruiters of analytics graduates. In some cases, they were looking for the Superman type model of a person who can do everything, but that was pretty rare. I think only 2 people really worked in that way, where they wanted someone who could do the whole thing, who could do the technology, who could do the geeky bit, who could do the nerdy maths bit, and can talk to the business people as well. So that was a fairly rare thing, and many of the interviewees actually expressed doubt that such a thing was possible or desirable. But that aside, we found 2 main models of working. The first would be the one most familiar to us probably in this room, where we had OR type people leading all of the main stages, from scoping the project to managing the data, building the model and implementing it. And what we found with most of these is they would use IT developer type support, but on a more ad hoc basis. So resources could be brought in as and when needed. And in some cases, the results of the model will be passed back to a developer type to operationalize and put into the enterprise systems. So around half of the people I spoke to worked in this kind of way. But we also saw another group of people who were doing things in quite a different way, where they would have OR type people or business analyst type people involved in the scoping, but then the analytics itself was being performed by these more techie teams, by developers, and implemented into systems by them, sometimes with the help of OR type people in terms of making the model stick and the insights stick. So again, I think employers are also taking this two-tiered approach. Some are taking the more traditional OR type way of working, using OR type analysts, sort of people that these business analytics courses might generate, and others are taking more of a data science route into the more IT end. Finally, I know I'm sort of bombarding you with methods very briefly without explaining them properly, but we did also do an analysis of job adverts to see what skills are more common in OR versus analytics jobs. So in similarity, they have things such as quantitative analysis, unsurprisingly, big data, management, communication and consulting skills, and we saw correlations between marketing domains, finance domains, and the programming languages SQL, C and C++. In the OR job adverts, you are more likely to see requirements for modelling, in fact for machine learning, and also for process monitoring. They're more likely to include project management skills, and the areas involved, perhaps unsurprisingly, considering OR's history, it was more likely to include manufacturing, supply chain, operations and engineering. We also saw more OR jobs requiring R, SPSS and MATLAB. In terms of analytics jobs, we saw a much higher demand for programming, a much higher demand for IT architecture knowledge and for business intelligence. And we're also more likely to be involved in marketing, e-commerce and advertising, and there was a considerably more demand for web language skills. So where am I getting to with this? I think basically what my conclusion is that there is really a two-tiered system going on here. There are roles out there that I would call data science type roles and roles out there which I would call more OR roles. Obviously there's plenty in the middle, but it seems there's enough separation in these two areas, okay? So I come to try and give you a definition of what I think data science and OR is in this context. I did find a good quote, but then I couldn't find it again, so I've kind of paraphrased it and made it up a little. But I'm calling it an application area for a variety of other disciplines, particularly maths, statistics and econometrics, where the focus is upon real-world problems and decision-making. Does that sound reasonable to you as a definition of OR? If not, you can beat me up at lunchtime, okay? So with that in mind, I tried to put something forward for the nebulous data science profession. And I would call it, again, an application area but particularly for high-performance computing and machine learning, where the focus is on, again, real-world problems, but deriving models from large and complex data sets. So I think we have these two ways of doing analytics out there, was the point I'm trying to get to here. So if that indeed does carry on, and we have this split between data science and operational research, I think there is, it's a slight detour, but I think there is a warning sign out there. I mean, data science has this sexier reputation. The name itself makes you sound a bit like you're some kind of experiment scientist on Star Trek. Operations research, we've got a slightly bit more of an image problem in comparison to data science. Obviously, Ryan Gosling is sexy, especially now he's in Blade Runner, but I think OR doesn't quite carry the same cachet. It does sound, for a start, a bit like we're going around studying what surgeons do, which isn't necessarily a good description. So I think it's something that's worth noting. I think we do need to be cautious of computer science's encroachment into our space, if you like, and the growth of these organisations that are taking a more machine learning approach. So, moving on from the degrees currently on offer, I'll just give you my thoughts a bit on some of the online courses out there. Has anyone used these MOOC type courses, Coursera's? Yeah? And what was your experience? Is it good? Yeah? Well, I think they do have a lot of very good courses. Coursera and edX are two I would flag. They are basically offering undergraduate courses online for free. So they're typically ones that are actually offered on their programs. You then have a second class of groups such as Udemy, Udacity and Lynda. These are more training orientated, really. They'll focus on practical software and things like that rather than academic. And typically these are paid for. And then of course I had to mention that a lot of universities are offering distance learning in analytics type subjects, but obviously the costs are quite a bit higher for those. Some notable ones that have a good cachet. So Andrew Ng from Google and involved in the deep learning scene, he's got a very famous course in machine learning, which is available on Coursera and YouTube. You can just watch it on there. That's worthy of note. John Hopkins does a data science specialisation on Coursera, which I hear good things about, mostly based around R. And an interesting one, Georgia Tech and Udacity are now offering an online degree as a series of modules on the Udacity site, which I think is relatively cheap for a US degree. However, in the literature, these are not without issues. The dropout rates are staggering on a lot of these, exceeding 90%. So very few people are actually completing the courses. I think in general, it's easier to walk away from an online course than it is to walk away from a real teacher and real classmates and so on. Okay? Standardly, they work far better on the objective topics than the subjective ones. Partly this is due to marking. So when you have a large class, if you have a class of thousands, if your marking involves, can you do a maths equation and produce a sum? That number's either right or wrong. Can you create a program? That program either works or it doesn't. It gets far harder if we want to think about the softer skills to make that work in a MOOC environment. And I also would raise the question what it adds to your CV. Now, the people I interviewed, they were not too sold on the value this adds onto someone's CV. I think it would definitely be a nice thing to have if you have done these courses, but the employers I was speaking to certainly were querying the validity, and they weren't completely sold on the testing process and the usefulness of such a course. And I think ultimately they don't have the same institutional authority that a university-based degree would have, and I would argue that the CAP would have. Final point to notice, there are other certificates out there, a lot of them coming from the specific software. So SAS has a business analytics one, Microsoft and Cloudera, Hortonworks, a lot of these other companies are now offering certification. The status of these is arguably a bit higher, but it does really tie you into a particular tool set. So I think if you're going down a route where you're definitely going to be working with SAS, or you're definitely going to be working in Microsoft Azure, some of these things may be worth doing. But in terms of giving yourself a general qualification, I'm not so sure that they are that. Okay, so that's my kind of background on the space and the competition. I've got about maybe 5 or so more minutes about taking the exam. And I'm happy to ask extended question and answer session of anyone who's interested in doing it, or come and collar me at lunchtime and I'll tell you some more. So if you go onto their website, and as is typical of American sites, you have to obviously sign up and give your email so they can bombard you with spam, but you can download the handbook from there, and it walks you through really the contents. I'd also thoroughly recommend, they've published quite a bit about the process behind them getting there. For background research, it'll be worth looking at some of these papers to really see their thinking going into designing the course. In terms of what you're going to be asked in the exam, if you are doing analytics on a day-to-day basis, a lot of the questions you will find easy. But they do cover quite a wide range of techniques. So you certainly would need to be fairly fluent in OR. They are certainly at the business analytics OR end rather than the data science end of testing, okay? So you'll have to know quite a bit of OR, but you'll definitely need to know, so the topics we're covering here at this conference, you'll need to know a lot more data mining and the basics of machine learning than you would in a standard OR exam. And they have quite a surprising amount of questions, I found, on business intelligence and performance management. So some of those concepts would be useful to cover. And given the scope and the basis on the life cycle, there's quite a few consultancy type questions, both at the problem framing end, but also at the more selling end, the selling of results end, I'd have said. I definitely advocate being a good student, do your research up front. I always obviously shout at my students for being so late to handing everything in and not starting till late, sorry sir. But of course, when it came to me doing the exam, I did nothing for 2 months and then just crammed it the night before. But luckily, it is the sort of exam, I think, where you can get away with that to a certain extent. But do be a good student if you can. And ultimately, it's multiple choice questions. So a lot of the time, you can apply some degree of common sense to it. I wouldn't rely on that, but sometimes it does jump out. The answers are gettable by process of elimination. That was pretty much all I found to say on the subject, other than to give you a few comments on whether I think it's for you. If you are trying to get more to that data science side, I don't think that is this. This is far more at the OR end of analytics. So a sort of checklist I put together, I think it would be suitable. These are the main things that I would use to base as the criteria. I would thoroughly recommend it to people who are already working in analytics, preferably if you're working in that end-to-end kind of way from framing to the end, because otherwise you will have holes in their questions. You definitely need to have a good working knowledge of OR and the basics of machine learning. It's very good because it is a vocational-based certificate in the sense that it's here to reward your work experience, not just your academic knowledge. One thing that really attracted it to me was that I felt I had that above experience, but my academic qualifications were not necessarily in the right titles. My first degree was in film studies, believe it or not. Okay? So I found it particularly useful from that point of view. And more generally, if you just want to do something that shows that you are up to date with these trends, I think it does a good job of that. And that, I think, was all I had to say. So nowhere near an hour. The upside is you can go to lunch early, but I'm happy to ask any questions either here or one-to-one later. Okay? Thank you, Ruth.